Introduction to the metric tensor. Gij يساوي لنا E1 في E2 E2 في E1 إلى En في E1. بعدين العمود الثاني E1 في E2 E2 في E2 إلى En في E2. وبعدين كما ترون آخر عمود هو E1 في En E2 في En إلى En في En. And inner products in curved space-time. Basis vectors. In any vector space, a set of basis vectors spans the space. For 3D space, a typical choice is E1, E2, E3 in brackets. In Euclidean space, basis vectors are often chosen to be orthonormal, perpendicular, and of unit length, satisfying EI times EJ يساوي لنا delta IJ, where delta IJ is the Kronecker delta. Any vector V in the space can be expressed as a linear combination of these basis vectors. V equals to V to the I EI, where V to the I are the contravariant components of the vector. Change of coordinates. When changing from one coordinate system x to the I to another x to the n, the basis vectors transform according to the Jacobian of the transformation. The new basis vector E dash I relates to the old ones E j as E dash E equals to the derivative, as you see, partial x to the j over partial x dash I times ej. This shows that the basis vectors transform covariantly with lower indices like covariant vector components. Since V is coordinate independent, its contravariant components must transform inversely. V dash I equals to delta x dash I over delta xj vj. We can denote dxi over dxj as a to the ij, so that v dash I equals to a I j v to the j. Then the inverse transformation, a negative 1 to the j must satisfy a to the negative 1 to the j sub I. A to the I sub k equals to delta to the j sub k. Example, consider a simple rotation in 2 dimensions. Let the old coordinates be x, y, and new coordinates be the ordered pair x dash y dash rotated by an angle theta. This transformation is x dash equals to x cosine theta plus y sine theta. Y dash equals to negative x sine theta plus y cosine theta. The transformation matrix for the basis vectors is then del to the ordered pair of xy over del ordered pair of x dash y dash equals to cosine theta sine theta, and the next column is negative sine theta cosine theta. Then the new basis vectors are e dash sub 1 equals to cosine theta e1 minus sine theta e2. The e dash e2 is equals to sine theta e1 plus cosine theta e2. Inner products. An inner product of two vectors can be generalized in the language of tensors by introducing a metric tensor gi sub ij for two vectors y to the I and v to the j. Their inner product is, as you see in these brackets, uv equals to gi j u to the I, v to the j. The metric tensor g sub ij is a symmetric tensor that defines distance and angles in a given space. In particular, g sub ij equals to e sub I times e sub j. From this we can deduce that g sub ij is symmetric. In Euclidean space it is identify matrix.